Hello everyone, I am Vignesh and today we will be learning about the forest plot. So the forest plot is a graphical representation of or to represent the results of a meta-analysis, and they are a key way for researchers to summarize data from multiple studies which ask the same question. They allow you to compare the results and the quality of different studies. How do we interpret a forest plot? Let's go step by step. So every forest plot has two axes. One is the horizontal axis and the other is the vertical axis. The horizontal axis represents the statistic which the studies show. For example, this could be a relative statistic like an odds ratio or a relative risk, or it could be an absolute statistic like mean difference or standardized mean difference. The vertical line, the vertical axis is called the line of null effect, which is placed at the value where there is no association between the exposure and the outcome. For an absolute statistic like mean difference or standardized mean difference, the line of null effect will be at a value of 0. Whereas for a relative statistic like odds ratio or relative risk, the line of null effect would be at a value of 1. Coming to the individual study lines, now each horizontal line on a forest plot represents a separate study which is being analyzed in the meta-analysis. Each study result has two components. The first is the black box, which represents the effect size. And the second is a horizontal line, which represents the 95% confidence interval of the study result. The size of a black box represents the sample size of that particular study. If the size is more, it means that the sample size is more. Usually, but not always, studies with a bigger sample size have a narrower 95% confidence interval. The 95% confidence interval represents the range of values within which the true value would lie 95 out of 100 times. If the 95% confidence interval crosses the line of null effect, it means that there is a chance that the true value could be null. In other words, any study line which crosses the line of null effect does not have a statistically significant result. The diamond at the bottom of the forest plot represents the pooled effect of all the studies in the meta-analysis. A vertical line through the vertical points in the diamond would represent the pooled effect size, and the horizontal points on either side represent the pooled 95% confidence interval. Now, if the horizontal points of a diamond cross the line of null effect, what does it signify? Correct. If the horizontal points of a diamond cross the line of null effect, it means that the combined result of all the studies in the meta-analysis is not statistically significant. Coming to the rest of the forest plot, to the far left of the forest plot is the name of the lead author for each individual study and the year of publication. To the immediate left of the forest plot are two columns depicting the number of study participants in each group. For example, this could be an intervention versus control group, or it could be a case versus control group. The column on the far right gives the results of each study in the numerical form. Some forest plots have an additional column for weight. Now, the weight indicates how much influence a study has on the overall effect. The weight of a study is determined by its precision. Coming to study heterogeneity, it's an important concept. Although different studies in a meta-analysis test the same intervention, they usually do not give the same results. Now, if the differences in results are caused by chance, we have nothing to worry about. But if the differences are caused by something other than chance, we need to be cautious in how we interpret the results. To assess the consistency of the individual studies, we use a statistic called the I-square, which represents the heterogeneity. The rule of thumb is that the I-square value should be less than 50%. If it is more than 50%, it indicates that the papers could be inconsistent due to some reason other than chance. That is, the studies have high heterogeneity. Thank you.